You guys are going to love this. I couldn't figure out where you all were because I was in the wrong class. It's the second to last day, and I was in the wrong class. What a crazy person. So, yeah, I was in my 9 o'clock because apparently I decided to start the day over. I don't know. But I'm glad you're here, and I'm here. So that's good. All right. Well, welcome, welcome. About half of you are done with your oral final. That's nice. Nice for that half, right? All right. Some of you still have today, and some of you have tomorrow. So I look forward to seeing you. Everybody's doing great, being prepared, like has their screen ready to share or a whiteboard or whatever they're doing. So that's very helpful. And they know which question they're going to do, right? Which one they chose. So that's really good. Those of you that have already gone, maybe you have any advice for those people who are still to go, and don't say like the answer to number 6 is. Don't say that, but maybe you have some helpful hints to the people who still have to go. Like I would say one hint from me is if one question starts going not well for you, it's okay. Like it's only one question. So you can recover on the next question. So don't get all inside your head and anxious and be like, oh no, right? Because it'll be fine.
That was definitely me yesterday during it at one of the questions. Like you'd asked me to do it a specific way, and I just got so lost in my head, and then I just got distracted. And I mean, I think I lost like maybe a point off it. So like as long as you know what you're doing, it shows that you know what you're doing and that you understand the concept. The rest, I mean, just comes and goes pretty easily.
Yeah. And it's always hard. I think Jessica and I talked about it being hard to predict what questions I'm going to ask, right? So that's the hard part. The part that you do, that you prepare, is the easy part, right? Because you're like, oh, I know exactly what this question is. So for those of you who haven't gone yet, think about what I could possibly ask you. Because what I noticed was, oh, yeah, Karina's got great advice. Practice your vocabulary and read your questions thoroughly. I noticed that students who are over prepared oftentimes have answered at least one of my follow-up questions, and I don't need to ask it, right? I can just go, oh, look, they already did that. So if you can think of what else I might ask, that's a great strategy. And definitely read your questions thoroughly. Okay. Just making sure I got everybody who's here. Okay. So yesterday we did operations on decimals. Yeah. And you might have thought it was a little weird. Did anyone think it was a little weird? The things that were going on, like with fractions. We did so much fractions. I keep saying stuff with decimals, and then my whole handout has fractions on it. And you're like, what is wrong with this lady? Like, does she not know what decimals are? Because I know what decimals are. So if we talked about adding decimals, right? You're like, oh my gosh, everybody think of what they do when they add decimals. Just think it up, what you do when you add decimals. What's your algorithm? Sorry, I just feel, oh my gosh, I don't know what I just did, but it was bad. I just deleted a page in my notebook. That's not good. Oh, I figured it out. I was on week 6. I couldn't figure out why I was so confused at why the information was not what I thought it was. Okay, so think of your traditional algorithm for adding decimals. Everybody have it in their head? All right, so tell me, is your traditional method, tell me how many of you would say this, line up your decimal points and add them. Yeah, how many of you that's true, right? You're like, that's exactly what I was gonna say. Yeah, okay, what's interesting is that's actually no different than adding up whole numbers, right? When we add up whole numbers, some of you are like, wait a minute, there's no decimal points in whole numbers. So how am I going to line them up? Well, that's my point. My point is when you add numbers, all numbers, you line them up by place value. Whether or not there's a decimal point there is irrelevant. Have you ever worked with a kid? This is my favorite mistake that kids make is you're adding a row of numbers, just whole numbers. Am I sharing my screen? Thank goodness. All right, so let's just say you're adding 3 plus 50 plus 7 plus 894. Yeah, you're adding that. If you've ever worked with kids, you'll see kids do something like this. 3, 50, 7, 894. You're like, what? What just happened? Right? And you're like, no, that's not how we add. You need to line them up by place value. And they're like, okay, why? Right? And then you can reinforce all those things that we learned at the beginning of this class. But then it gets a little trickier because once they learn that, they're like, okay, I understand that. I know how to do it. But if some of our numbers have decimal points and some of them don't, then it gets even more random, right? You see all kinds of craziness go on. You see things like this. And then teachers say those things that are line up your decimal points. And the kid's like, okay, line up my decimal points. Okay, so I'm gonna line up my decimal points. And then they go, but this one doesn't have a decimal point, right? And so then you ask them, okay, if you put a decimal point in that, where would it go? Have you ever asked a kid that? If you put a decimal point in there, where would it go? It's the biggest guessing game you've ever heard. They're like, and they're like looking at you to see if you're going to give them a clue, right? And they're like, and they're trying to put their decimal point there and they're waiting and waiting for you to acknowledge something. And then they go, there. And you're like, wait a minute. Like, how is that even possible that you thought it would be there? It's because they're not thinking about the meaning of the decimal point. You just said line them up, and they're like, well, it'd be nice if it was there. It would make me feel good if it was there. And so I've had conversations where I'm like, is that still the same number? And they're like, yep, still has a 5, still has a 0, just has that cute little dot in the front, right? So there's a huge problem with understanding what's happening here, okay? So before you teach that algorithm of line up your decimal points, first of all, don't ever teach that, right? You can say, line up your numbers by place value, that's fine. But don't just always use a decimal point because that's what throws them off. What if there's no decimal point there? So yesterday we did fun things, yes? Like this. 5 and 47 hundredths plus 3 and 78 hundredths. Yeah. And then some of you did this, 547 hundredths plus 378 hundredths. Yeah. And some of you are like, I'm not sure I buy that. Like, how did you know that it was just 547 over 100? Well, if you don't believe it, try to convert that to an improper fraction. 100 times 5 plus 47. Look, you're still going to get that same thing. Remember how we said decimals are read by where they end? Yeah. So if I read, let's just say I did it this way, right? I do this problem, and I'm going to add now 547 plus 378. By the way, I hope you didn't forget any of the other things we did. You could add like this, 500 plus 300, right? Plus 40 plus 70 plus 7 plus 8. Remember that? Yeah. And we could say, oh, that's 800, that's 110, and that's 15. I'm going to add, 800 plus 100 is 900, 10 and 15 is 25. So I really get 925 over 100. Yeah. Sound good? You're like, oh my gosh, is she kidding me? Did we really learn all of this? Yeah, you did in 7 short weeks, because we really didn't learn it this week, right? So yeah, it's crazy the amount that you guys learned. So when I read this 925 hundredths, I need that to end in the hundredth spot. So I work backwards when I do it. And I say, okay, 925, I need it to end in the hundredth spot. So I know my decimal points here. I'm going to have 2 places because this is the hundredth spot. So I'm going to put my 5 here, my 2 here, and my 9 here. Yeah. So I worked my way from right to left to figure out what my decimal answer looks like. And that's going to help students see those connections to the powers of 10, where when I divide by 100, it really shifts my place value to the left. Yeah. If you've ever seen a kid or a teacher do this, right? These little loopy guys, that's what they're doing. Yeah. Okay. And you could do subtraction and then multiplication. I don't want to erase all that in case anybody's reading it. So I'm going to look at this problem right here. 3 and 14 hundredths times 9 tenths. And I know I showed you a different way yesterday in that decimal booklet, but can we think of Poy's 4-step method and have a conjecture or an estimate that I know is too low and one that I know is too high, or just about what my answer will be? So if this was whole numbers, it'd be a lot easier, right? If it was just 3 copies of 1, hey, that's fine, right? 3 copies of 1, I could do that. That's 3. 3 times 1, that would be the best problem ever. But when I look at this, 3 and 14 hundredths times 9 tenths, well, 3 and 14 hundredths is a little bit bigger than 3. And 9 tenths is a little bit smaller than 1. Right? Do you agree? So my answer should be close-ish to 3. Yeah? Do you feel good about that? And a lot of you will go, oh, I can even estimate, even if I didn't say that's 1, I know that 3 times 9 is 27 because I just know that multiplication table. So I'm guessing it's going to be a little close to that, right? So I can say, okay, I'm going to multiply 314 times 9. This is your traditional algorithm, 314 times 9. The nice thing about that is I can do that however I want. I could do, except for if I'm writing in highlighter. So I could do 310 and 9, right? Oh, that's a 4. Helps if you do the right problem. 4. And then times 9, right? So I'm going to get 2,700, 90, and 36. I'm going to add all those up. right? So I'm going to get 6, I'm going to get 12, 8, 28, 26. Now, I said my estimate, it must be right around 3. Yeah? So if you know your answer is around 3, where would you put your decimal point?
After the 2.
Yeah, between the 2 and the 8. Ta-da! I didn't have to count things, right? I just know it's there because it makes sense to me. Then after I figure that out, somebody, some teacher or some textbook is going to tell me, count these. Yeah? I'm going to go, oh, 3. And then, oh, that's where that 3 comes from. That's your traditional algorithm, right? Counting those. But we should be thinking way more. Yeah? Okay, did anyone have any epiphanies about decimal operations after yesterday, or concerns or experiences with kids in a classroom dividing or anything, or multiplying or adding and subtracting with decimal? When you were doing the problems, were you having flashbacks? Was anybody having flashbacks to elementary school? Yeah. When you did long division, let me see if I have one of those division problems from our notebook. That decimal operations booklet. I thought I had it sitting right next to me. Like when you had a problem that was 2 1/10, 2 1/10 divided by 7/100. Yeah, I'm going to move it down here so you can see it. 2 1/10 divided by 7/100. When you were a kid, you wrote your problem like this. What's the first thing your teacher told you to do?
Eliminate the decimals.
Yeah. And you were like, okay, what am I supposed to do? And then your teacher magically did these things. Yeah. And then went like this. And you were like, okay, sounds good. I believe you. I don't know what just happened, but I'm there. And then you played the long division game that you were bad at to begin with, right? Remember when we reviewed long division and you're like, oh, I'm bad at this game, right? Yeah, because it's a hard game to play. Yeah, so none of us really knew what was happening here. We were just playing along. So what I showed you yesterday in that decimal worksheet is you're really multiplying by a power of 10, right? You're really multiplying by 1, but you're multiplying by a power of 10 in the numerator and denominator to make it make more sense in our head. But did it really make more sense in our head? I don't know that it really did. Okay. What's interesting is if you think of it like this. Sorry, let's do it like this. 21/10 divided by 7/100. That's what this really is, right? Yeah. Well, if I divide tenths by hundredths, I might have a problem, right? I might go, I don't know what that means. Tenths divided by hundredths. I don't know if I know that. But if I made them the same, if I made it hundredths divided by hundredths, getting a common denominator with division. Remember when we did that with our blocks and our fractions? Yeah. So if I just did this, ooh, mathematically, what did I just do? What did I just do mathematically when I put that 0 in that numerator and denominator?
Multiplied by 10.
I multiplied by 10 in the numerator and denominator. So I really just multiplied by 1. Yeah. Okay, so now I can do it. Because now, remember when my denominators match? I don't care about my denominators, right? So I have 210 divided by 7, and I'm going to get 30. Notice I would get that same thing here. So we just have to be thinking of things, thinking things through when we do things. Amanda, you've tutored people in 6th grade. 6th grade, this is big time, right? Decimal operations, 6th grade. Anyone been in a 6th grade classroom? I mean, besides when you were in 6th grade? Yeah, so 6th grade, this is a tough crowd, right? 6th grade, this is a tough sell. You're like, how do I teach this? Yeah, it's hard. I've seen amazing things go on in classrooms. Amazing things go on in classrooms, okay, with kids. So if you looked at that first one, 24 divided by 8 versus 2 4/10 divided by 8/10. Did you think about this? How many copies of 8/10 are in 2 4/10? Yeah, did you think about that? So let's think about that. Here's one hole, 2 holes, and then I'll draw my third. And let's say I break it in tenths. These are beautiful drawings, by the way. All right, so I have all of this one. I have all of this one, and I only have 4 of these. So I'll highlight. I have all of this, and I have 4 of these. So there's my 2 4/10. And I want copies of 8/10. So I'll circle them, right? 1, 2, 3, 4, 5, 6, 7, 8. There's one copy. 1, 2, 3, 4, 5, 6, 7, 8. There's 2 copies. 1, 2, 3, 4, 5, 6, 7, 8. Oh, look. There are 3 copies of 8/10 in 2 4/10. Do you see how that relates to my grids that I was using before? Yeah. So you do a few of these. Thank you, Karina. So, and think about it, if you had 24 hundredths divided by 8 hundredths, I would have a similar picture, but it would just be little tiny boxes colored in, right? I would just have one grid with 24 little yellow boxes colored in. I'd have to divide it this way. So here's my 24 colored in. And I want to find copies of 8 hundredths in there. So I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. There's one copy. 1, 2, 3, 4, 5, 6, 7, 8. There's another copy. And 1, 2, 3, 4, 5, 6, 7, 8. There's a third copy. So that would be 3. So when my place values match, I'm going to get a whole number for my answer. Weird. When they don't match, I'm going to shift my place value one way. Tricky. Yeah, kids recognize these patterns, and kids will say tenths divided by tenths is a whole number. And you'll be like, what? Tenths divided by hundredths are tenths. Again, you'll be like, what? Because what they're noticing is that the decimal is just keeping track of place value. That's all it's doing. It's not affecting my quotient, the digits, it's only affecting place value. Weird. Oh my gosh, Karina, thank you for saying that. That is so true. Kids are so smart. They know amazing amounts of information if we let them think. If we let them think. If we try to teach them algorithms first, they're just mimicking and copying. and they're not thinking. Let them think, let them build, let them figure it out. I don't know why I just did that, because we just need to go up here. Okay. That being said, it's your turn to think. I'm going to give you a Jamboard. I know we haven't done a Jamboard in a while. Did you miss them? Were you crying inside because we hadn't done a Jamboard in like 4 days? Yeah, I thought you were. It's true. I'm going to put you in breakout rooms. This is what I want you to do. And I want you to talk in your groups. I know it's a stretch. It's almost the last day. You're like, why am I still even talking to any humans? Right? It's okay. I want you to figure out, and I want you to try to keep an open mind, not think of your algorithms that you already know. Sorry, I'm having trouble copying this for some reason. It keeps wanting me to, there we go. Keeps wanting me to change my slide. Okay. That's what I want you to do. So on this first picture, it says shade the fractional amount of the grid that's named. So you might have different ideas. Like Amanda might have a different idea than Essie. Sunita might have a different idea than Brianna. Elena might have a different idea than all of you. So it's fine. Make duplicate pages if you want. So, and then think of the decimal name. But I'm really interested in how different we think. Okay. So I'm going to put you in groups. Maybe. Okay. And there might be more random than you want them to be. But it's okay. I told you I went to a conference and they told me always do random groups. And I was like, that's painful for me. I'm not good with just random groups. It's hard. Okay, so, but I'm trying it because I shouldn't argue with this. And then we'll come back in just a few minutes. There's several pages. Just work through as many as you want. You can all write on one document. You can have one person share and the rest of you just talk, you know, and then one person can write, because I know it's a challenge on these Jamboards. And I'm going to come visit you. Okay? So just try it. Hi, guys. Everybody else is coming back in a minute. Hello, hello. Welcome back. Okay, so some of you are like, that's the best day ever. We should work in breakout rooms the whole time and she should never come and see us. That should be the gig. Just kidding. But believe it or not, we got through almost all my slides except for the very end, because you were working your way through them in the Jamboard. And now the only problem is there's not more of me, so I can visit you throughout. And the only problem is I didn't tell you to share the Jamboard with me, because then I could see all your Jamboards at once, and then I would know when to come and visit you. But that's my bad. So poor group 8 was neglected because I only saw them for like 2 minutes. So, but that being said, I hope when you were working your way through this, you were understanding what I was explaining, what I do in my own classroom. when I do this in my own classroom, I have laminated sheets and every student works on it individually. And then I scaffold how they're going to share their information because it helps students, and they don't work all the way through. We work for a little bit, pause, share, work for a little bit, pause and share. And then some of you have been working on that repeating decimals packet and you noticed some things. So I'm going to ask one group, and who was it? It was Hannah, Jessica, and Karina. Is that right? Was that your group? Can one of you share your screen so we can kind of see your Jamboard?
If sure.
Oh, I gotta stop sharing. Hold on. I gotta stop sharing mine. Okay.
Okay, here's ours.
And go to the very first slide. All right, so if you guys look at this very first slide, some of you are like, oh my gosh, there is a group that did that, right? And there might have been more than one group, right? But this group was the students that I would save for last when they're sharing, because their ideas are a little more different and might be a little more complicated for some, or just a new light bulb goes on for a student, right? They thought they had to do it a specific way. Look at part B especially, right? So in part A, they did 4 sections. And so in part B, they did 25 sections. Nice, very unique way of looking at it. Go to the next page just so we can see it. Wait, where'd your picture go? How did it get blank?
I have no idea.
I don't know.
Go to the next one.
See,
yeah, there was lots of coloring there before. Okay, weird. Okay, this was really shaded and I did not erase it. Don't worry about it, you're okay. So, but you can see these things. Now, go to the next slide for me. Okay, we talked a little bit, or I did with some groups, that number 1 and number 3 would terminate, but number 2 and number 4 would repeat. Does anyone know why? Can you share why, Amanda?
I got it from the repeating decimals homework. In the denominator, if the prime factorization has numbers other than 2, 5, or 10, it's going to repeat.
Nice. So if the prime factorization of the denominator of a simplified fraction, make sure it's simplified first, by the way, just in case somebody tries to trick you, okay, has a factor other than 2 or 5, and you don't even need to say 10, Amanda, because 10 has prime factors of 2 and 5, so you're good, then it will repeat. So if you notice, if I do the prime factorization of number 2, I'm going to get 2 times 3. It's that 3 that's making it repeat. And then when I have number 4, the prime factorization of 7 is just 7. So that's a number other than 2 and 5. Anyone know why it's 2 and 5? Any ideas?
is it because 2 and 5 were both factors of 100?
Go lower instead of 100.
10.
Yeah, what is our system based on? What is our number system based on? 10. What's the prime factorization of 10? 2 and 5. So it doesn't have to have both 2's and 5s, but if it has only 2's or only 5's or only 2's and 5's, then it's going to terminate. Otherwise, it's going to repeat. Wouldn't that have been nice to know when you were a kid? Yeah, why don't they tell us these things? That's a great thing to know. Okay, so it's 1:20. We didn't get to the last 2 slides. That's okay. We'll pick them up tomorrow. Karina, you can stop sharing. Thank you. Every group did great. I appreciated all your information. You guys were working very hard. That bottom right-hand corner of the percent fraction decimal homework is a beast, or a little bit harder. So we can talk about that tomorrow for warm-up. Your exit ticket I already put in the chat. So that percent homework, fractions, decimals, and percents, you just did it on your Jamboard. If you didn't quite finish, that's okay. if everybody could share their Jamboard with me, that would be nice. Pick somebody in your group. And then I know that, who was it? Hannah L has a question from the more homework that I'm going to go over in just a second. It'll be real quick. So you don't have to turn them in, just share it with me. If you just share it with my email address, I'll put it right here in the chat. And otherwise, have a great day. One more day. One more day. You can do it. You can survive me. And then some of you have 8 more weeks. Sorry about that, Chief. Okay.
If we share that Jamboard, do we still have to do the worksheet? Because the worksheet's technically kind of on it.
Did you do the worksheet in the Jamboard?
Yes.
Then you're good.
Okay, cool.
Yeah. Okay. I'm going to stop recording. Anybody have any questions besides Hannah?